So yeah, hi. I'm gonna talk about Holey today towards incomplete but executable programs. If the incomplete is shifted, I think I spent quarter of an hour in PowerPoint trying to center it. It's not possible because it changes every time you start the presentation. Who of you wrote code like this? Oh. Perfect. Who regretted code like this? Okay. Okay, then I'm finished. But not only code is written like this. There are different examples as well. So I found these trash containers, and they have like to-do comments on their outside. Somewhere in Finland. They were actually, so I don't know about this one, but the other one was empty and it had no to-do comment on it. Or just recently in Liverpool, I love this to-do comment on this construction site. This car park is now closed until a later date. Yeah, quite specific. But there are also other things that act like to-do comments in the real world. Despite this screen is not the real world, it's not the real Post-it. But Post-its have like certain properties that make them act like to-do comments. They are of limited size, so they should usually capture one single thought until you use like huge Post-its. They have a spatial property which conveys meaning, so this is the second point now. They are physically unique, and this one's not, which kind of fosters natural affordances to interact with them. And they're ephemeral. They reduce effort justification. As I'm studying psychology as well, I'm hugely aware of these cognitive biases, because this is mainly our study program. So it's quite easy to throw Post-its away. I don't think it's that easy to throw to-do comments away, because they are not that visible. So there are, now it's gone. So there are certain things that you could compare to-do comments to, like the Post-it analogy. And as Kent Beck put it, the goal of software design is to create chunks or slices that fit into a human mind. The software keeps growing, but the human mind maxes out. So we have to keep chunking and slicing differently if we want to keep making changes. So another to-do comment in the slides. So the first kind of property of to-do comments, just a side note, so this Holey topic was like my master thesis topic, where I did some research about this way longer than I expected. The first property is like reducing cognitive load, Okay, perfect, thanks. It's like reducing cognitive load. As we have already seen, like with Post-its, it's the same. You can just pin something somewhere, or with these containers, you know that they are trash containers and they have to be deleted somehow. A second property that kind of emerges is like exploring these ill-defined problem spaces. In psychology, there is this research space of complex problem solving and programming, coding, software development, however you define it, is definitely a complex problem. Even a Hello World program can sometimes be a complex problem. So, and then they are well-defined and ill-defined. And software is usually an ill-defined problem, so you have to kind of explore the space you act in. So this is the second part that we're gonna look now. And to-do comments greatly can help in this area. So, there is a tool that's used for exploring these complex, ill-defined problems, which is like prototyping, or the Greek word prototypos. And literally translated, it means like protos and typos, which means the first or earliest pressing, sort, type, or sign. That's the true definition of prototype. We'll come back to this, because what prototyping in our industry, at least for me, looks now, is like this. So you have this evolutionary prototyping. And evolutionary and prototype don't really fit together if you look at the words and the meanings. So it's like you have this prototype at first, and then you're adding features, and then you're discarding features, and then you get this really nice code base with a really good architecture, because you're constantly adding the features. And then you've got all the features, and it's the final product. Of course, it's as simple as that. But as we have seen with the to-do comments, not only our, dare to say, imaginary world here has these prototyping problems, but there are real products that are really prototypes, I would say. So, as an example, this door lock, I would definitely classify as a prototype. Yeah, it's the left one you have to use. Then, yeah, a pretty famous one. I think it never left the prototype stage. I don't know whether this is an example for stream programming or it's something else, but I see a couple of prototypes in there. Just recently I had to get, I think, a new passport or something, and they kind of modified the screen in an interesting way. Okay. Yeah, yeah. I liked it because it's functional, and yeah. This one I'm not fully sure whether it's a quick fix or prototype, but in reality I'm never sure at all whether something's a quick fix or a prototype. Then I'm not sure whether this tried to be a prototype at all. It's definitely didn't work. As some software that I have to use, at least time tracking at work looks exactly like this one. And I'm absolutely not sure whether this is, or the person who mounted this trash bin read the Gang of 4 adapter pattern prior to mounting this. But yeah, it works, and it's 10 centimeters higher. Probably with some law in Austria. So, as we've seen in these real-world examples now, what runs, the code or the comments? Usually it's the code, and the comment is rewrite the comments for normally for the next person writing code, or for if the next person can also be us. So we are writing it for ourselves, but it's not meant as instructions for the computer or compiler or whatever. But can we change this? Is there a space that we can explore where those things we can mix them up and we can actually make use of this? So, taking a little bit a peek into this evolution, there are to-do comments like those that most of us used probably today, and there's been a bit of research regarding this. Like there was this PEP 350 code tags proposal, which tried to standardize a syntax for to-do comments in the Python ecosystem, but they rejected it because it's something that shouldn't be in the standard library. Trigit is an idea to write triggering code inside the code itself, and then it gets executed, and then you can actually modify the AST while the program is running. Kind of an interesting idea. I wouldn't trust too much. To do or die is, I think, a Python or Ruby library with one function that just dies, or the program dies if the to-do comment is too old. There's a C++ macro which like prints out the comment at runtime to bridge the gap between compile time and runtime. And then there are to-do trackers or editor features. And then there is hole-driven development. Who of you has heard of the term hole-driven development? Oh, quite a bit, probably in this audience, not the representing group. So this example is taken of the Idris programming language, and the idea is that you can leave pieces of your code unimplemented, and then the compiler helps you out with which expressions might fit in there, because the compiler knows a lot about the types and which expressions are in scope and so on. And it's usually used in strongly typed functional languages, and as far as I know, it didn't really find the way into industry. This is Hazel, which lifts these holes into a GUI space, so you can actually modify the source code via this livelets. And then, yeah, the origins go back to Coq and Acta, where they were called goals, and you use them to assist your proofs. Haskell, Hazel, and Idris are languages that also support holes natively. And then we've got this idea of simulating holes. After I read about this topic, I realized that people are trying to implement those holes in languages that don't have them natively. And like the not implemented exception in C# is like, I have to do something there, but it isn't faced, or that it doesn't surface at compile time. Your program crashes kind of expectedly. There's some research done in Java by the same guys that did Hazel. Then there's the 3 question mark operator in Scala. Martin Odersky introduced it to teach his students in class. So they just have to fill it like a fill in the blank exercise. And there's fatal error in Swift, I think, the to-do macro in Rust, and any and unknown in TypeScript. You could see them as holes, or yeah, however you want to see them. And there even like a hole like concept or post-it like concept in LaTeX, which I used to writing my thesis. And then there was one hole left in there because it was an example. So when I code, it usually looks like this, trying to fit pieces together. And I can really relate to this one. So, yeah, Edwin Brady, the creator of the Idris programming language, has this quote like, the compiler should be your lab assistant. I like to think of the machine not as a thing that checks my code, but like my lab assistant. We're gonna do some pair programming, me and the machine. This doesn't free you from knowing what you're doing, but it does save you from doing the step that really the machine should be able to get by itself. Like really sophisticated compilers and functional languages. When I was walking through Liverpool a couple of weeks ago, I read it as the happy hole until today, but the hippie hole is quite nice because I've never used this font in PowerPoint. So, so a short demo regarding this Holey thing. So the main result of this master thesis was like a library that acts during compile time and at runtime. So as you see here, this to-do comment, maybe it's better to put it a little, somehow zoom in. Few chance. Haven't used it. Okay. Of course not. Okay. Then I have to explain it. So on the bottom of the screen, there is this arrow panel, and suddenly to-do comments surface at compile time. So you see that there's actually something left to do. And then you can also use your to-do comments to actually create code like a hole, and then you've got something that you can run. Like this program is now runnable, and it now should compile the future of coding meetup and not meetup, future of coding thing. And I'm starting Visual Studio, I know, but there is this empty effect to say hello, and then we can also use things like peeking at the time. We can use something like in here to provide some value. So maybe we want to order 4 donuts, bar donuts. So we can use this query donuts or query donuts, and then you get these. And then on the bottom here you get like information about these holes during compile time, and the C# is not a purely a functional language, but you also get which variables are in scope. So you can actually simulate some of these things. And as I've got 1 minute left, there is one more thing I want to show you. Maybe we can create an order, and the order is string name and int donuts. So we could also use this now to print the order here. Order. And we can create an order and now ask for a value and prompt this. And now in the background, it creates a JSON schema of this object and creates, let's see whether it works. It starts an external application connected via WebSockets, or so here there is something happening, and then it creates a form based on these on the structure of the class, which you can use to externally inject values during runtime. So you can actually quickly prototype stuff, and then you can also use like automatic fill-in, which doesn't make sense, but it lets you experiment with your stuff quite fast. And then you also see like this, the program finished, of course. But you see the whole log, and I'm out of time, but this also works via WebSockets, so we could try this together to foster interactive prototyping. So yeah, this isn't, As Boris said, I tried to, yeah. Okay, perfect. Yeah. Okay, perfect. So yeah, maybe some future ideas are like cross-language support. I wanted to implement a Smalltalk example for today, but I actually didn't find the time. No, just not in the talk, but for today, to provide this Holey library in different languages. Because this tool, the WebSocket tool you saw, you can connect multiple applications to it. So you could connect the front end and the back end application, and then test like the interaction between it without using all these static values. And they get reported in your IDE using these linting things. So what you need is notion of comments, linting capabilities, and some notion of faulty behavior, maybe exceptions, errors, and some custom control structures, and then you can create it for whatever language you want. And I'm currently exploring this, and also with different extensions. But if you go to holey.dev, it's more of, I just put the paper up there. You saw this nice tweet lately. An old friend of mine once said his open source projects were not applications to be used, but arguments and theses for how software could be built. I think this is quite a nice and statement to put stress off of contributors and maintainers. And as Boris said, bridging islands. As I'm becoming a psychologist and a programmer, I usually don't try to bridge them, but I just run away from them. And if somebody wants to talk regarding this malleable computing, I'm currently building a desk, which is not projector-based, but touchscreen-based, but should include things of cameras and tracking and object tracking. So yeah, happy to talk, and thanks a lot.